Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let us jump to the next topic, part 2 of our course. So we will be dealing with specifications and building codes in this particular video. So let's start with the objective of the course. PhD provides fundamental concepts, principles, and theories under structural analysis and design of steel elements and non-structural. Now we have the major topics in this course. As I've said, we are now on the second video topic. Under this topic, we have subtopics, 5 of them, and we will start with the first one, that is module number 6. It's about specifications and building codes. Now, there are a lot of explanation already given to you in my courses, delivered as a discussion, lectures, and so on. However, I would like to summarize those things into this slide. We should agree that the design of most structure is being controlled by building codes and design specifications. And even if they are not so controlling, meaning the code, the designer will probably refer to them as a guide. So either way, the importance of building codes are always invaluable. Okay? No matter how many structures a person has designed, it is impossible for him or her to have encountered all of the situations. Okay? So each and every problem is a different one, particularly as I already mentioned that the design on a particular site is non-transferable. Okay, so we have a lot of discussion about that already, and we express so many aspects and the perspective why that is so. Therefore, let's continue that by referring to specification, we use the best available material on the subject. This is one reason why we are actually always using the code. Engineering specifications that are developed by various organizations present the best opinion of those organizations as to what represents good practice. Okay, so can anyone react if the audio is okay? Do you understand what is talking about? What we are talking about? Please react. So meaning to say, the code is a collection of best practices, not only good practice, because there are several people that are having so much experience on those fields. They are gathering their ideas collectively. They select the best practice out of those. So, and those are what we call experts, and those experts are making their contribution, and the group that they belong in a particular topic or main topic of the code. That is our what we call technical committee. So technical committee of that particular topic. So meaning to say there are several persons, there are several professionals, there are several engineers, there are several civil engineers, structural engineers that work together. They put on their best experiences together in order to have the best practices published by their organization. So these codes specify mainly, number one, minimum design loads. Number two, design stresses. Take note of these things. Number three, construction types. Four, material quality and other factors, number five. So take note of those important information that we will get out of the code. So these are the five. Okay. And we are taking note of them because we will use those information for our insight as a what? Learning engineer, learning design engineer for our what? Computation part. Okay. AISC and AASTO. Okay. AASTO meaning American Association of State Highways and Transportation Officials. We already talked about this on the other course, what we call the highways and railroad engineering. However, there is another one, AIC, and we already talked about this several times. That is American Institute of Steel Construction. So these are the organizations usually specifying the best practices. And since they are best practices, they became a standard. And after they become standard, they are usually become code itself because local authorities adopt those documents. Okay, so there are far fewer structural failures in areas that have good building codes if those codes are strictly enforced. Okay, so as you can see, our country will always have very good law, very good codes, but the problem is in the implementation. Okay, we usually have a very good law that doesn't be implemented. Okay, it's sad. It's sometimes a disgrace, but that is the reality in our country. So specifications prevent engineers from thinking for themselves. Okay, so the job of an engineer is to design, but it is becoming more and more what taking note of the specification, then use them. Taking note of what's the value in the table, tabulated value from the code, and use them. So what about our practice and experience of engineering wherein we are trained for problem solving? Okay, looking up from the table is not problem solving. So looking up from the table, we are what? Applying the code, but we are not 100% solving the problem. We are what? Using the experience of other. So in some aspect, that is true. However, what we are actually copying is not a hearsay. Okay, it's not a hearsay. It's documented. Before it will become a provision in a code, it must be documented. Okay, there must be no hearsay written on the code. Okay, must be documented, and not only documented, evaluated, analyzed repeatedly. Okay, so that's why we have a very good confidence that using those values, using those formulas, using those suggestions by the code is sometimes, although not an engineering job, okay, because a technician, even not an engineering graduate, can look it up from the table. Okay? So what is the difference of being an engineer and not an engineer? If you can just look it up from the table, okay? So our skill to what? To explain it using our what? Analysis and design is the difference, because even though we are looking it up from the table, we still have to prove it by computation. And your what? Your engineering plan approved by the local authorities are actually uh, not only a drawing. They have what? They have an analysis supplementary to that engineering plan. So if you can have an engineering plan uh, requested from the engineering's office, you might as well request the analysis pages. There are about 5 to 10 pages of computation, the analysis part. So it is good if you can also borrow those document and photocopy them. Okay, so in our country, national codes are the following with respect and related to our course. Codes are written not for the purpose of restricting engineers, but for the purpose of protecting the public. Take note of this main. I always repeatedly, time and again, telling you that the National Building Code and the National Structural Code of the Philippines, even the Blue Book, they are there to what? To protect life and property and public health. Okay? In addition, National Building Code has a fourth purpose, which is to provide public welfare. So there are 4 purposes from the National Building Code: protection of life and property, public health, and public welfare. So these are the current. These are the current. These are the updated. These are the latest version of those code. NBCP 2005 IRR. NSCP 2015. Okay, and the Blue Book 2012. So as you can see, Blue Book is 2013. That is the printing date. It is released first on 2012. That is why it is Blue Book 2012. But here, it is printed the following year. So there are several editions, so printing date. So that is edition. Okay. So here, NSCP 2015, that's okay. So these are the documents that we're going to use. Organizations specifying codes. It is impossible to cover every possible design situation from the point of view of organizations. So what are those organizations? AISC and AASTO. However, in our country, PICE and ASEP are those organizations locally. So PICE and ASEP would what recommend to the government agency, and the government agency will adapt and promulgate those codes. Right? So as I already mentioned in several previous modules. Right? As a result, no matter which building code or specification is used, the ultimate responsibility for the design of a safe structure lies with the structural engineer. Take note of this. Take note of this. Even if you are the design engineer and it is approved by the government, meaning approved by the building official, The building official doesn't have the responsibility. You are the one who designed the building. You are the ultimate responsible person for the safe structure. Okay, it's very important. Okay, very important. The intent of this specification is that the loading, note loading. What do you mean by loading? Recall your theory of structure. What do you mean by loading? Okay, the loading used for the design is the one that causes the largest stresses. That is the main philosophy of the provision of the code. So the provision of the code always specify loading that causes largest stresses. Okay, so take note of this, very important. And now we are going to the last slide, which is our challenge question. Question number 19. Grade designation of the reinforcing steel bar is also called. Grade designation of reinforcing steel bar is also called block. A, tensile strength. B, yield point. C, elongation. D, unit weight. So I already gave you several clues from the explanation. I did not specifically told you about this, but because of so much explanation, those are the clue hints that you can manipulate in order to come up with the answer. Okay? We already know what do we mean by tensile strength, what do we mean by yield point, how they are related to one another. We know what is elongation, we know what is unit weight. So that's all for this video. Again, this is Dr. EYPEI, preaching engineering for nation building.